Hey everybody, this week we're going to start getting into IMRT, or for this week more specifically VMAT. Okay, so we're going to start with Extremity. It's a really easy, simple one to get started with, just to get the basics down of how to create one of these plans, and then we'll gradually get more and more complicated as the weeks go by. But before doing any sort of plan, 3D or IMRT or VMAT, it's a good idea to understand a little bit about what you're trying to do, what the final product is that you want. So I'm going to include, this is a popular protocol for doing extremities, RTOG 0630. So I'm going to include this week. If you've never seen a protocol or done any protocol planning, which you probably have not yet, look through this whole protocol. This is how most of them are structured. If you come to section 6, that is specific to radiation oncology. You can read about how the doctors are supposed to create their volumes, all that type of stuff. But section 6.5 covers normal tissue constraints. And this is a leg, so we're not close to any, sensitive OARs. Really the only ones we have to worry about is this longitudinal strip of skin, which I have, and I'll show you in a second, but we want no more than 50% of that to receive 2,000, so remember that, and weight-bearing bone. So we do have one of those. 50% should be under 50 gray, okay? So those are the two that we really have to focus on. Also joints, where was that at? Less than 50% of any joints should receive 50 gray. So both the bone and the joint, 50% less than 50 gray. Then if we scroll down here to section 6.7, these are the real important ones, okay? So if we were gonna treat this patient on protocol, which we're gonna pretend like we are, we need to meet these per protocol constraints. If you absolutely 100% cannot meet these per protocol constraints, there are these minor variations, and those are acceptable. The patient can still have a minor variation and be on protocol. Major variation is a no-no though. We can't, the patient will basically be kicked off the protocol if you get a major variation. So we do not want to do this. For this case, again, pretty easy, so we should be able to do this. But if you'll notice, it's all about coverage, okay? So we basically need a minimum dose on our PTV of 97%. So what it's saying is they're defining a point as 8 cubic millimeters, so that's 0.008 cc's. So I'll show you how to look at that. So it's not a true min dose in terms of looking at the min dose in Pinnacle, or Eclipse, they are giving us a little bit of leeway. Usually it's, it would be, 30 cubic millimeters, so 0.03 cc's. That's usually what people consider a point in terms of looking at min doses, but this protocol is a little bit more strict. They look at 8 cubic millimeters, or 0.008 cc's. 95% coverage by our prescription dose of 50 gray, and then no more than 20% of the PTV should receive greater than 110% hotspot. So that's what we're shooting for. And then these are actually kind of secondary. If you read here, the wording say every effort should be made to avoid, treating blah, 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 all this stuff. But coverage comes first, then we should meet these critical structure constraints. Ultimately, though, it's up to the doctor. So if these are kind of contradicting each other or just really tricky, it's up to the doctor to ultimately decide what to do. But again, for this case, we should be able to meet these constraints and meet these per protocol coverage constraints too. Anyways, like I said, before you get started, since IMRT or VMAT plans can take a little while to run, you don't want to run a plan that's not going to meet these constraints for no reason, I guess is what I'm saying. So always should have a good idea of what you want before you get started. So let's insert a plan. Like last week, I want you guys to create your own patient and your own and import that structure set. But this week you'll look for one that has week 3 in it. Okay, that's the structure set you'll be looking for. But once you have that patient created, imported that structure set, create a plan. Okay, so to add my beams, I'm going to use what's called an arc geometry tool. So if I come in up here and go to planning, this first option is arc geometry tool. And all it's going to do is kind of give us a good starting point. So based on the size of this PTV, it's suggesting that we use 2 isocenters with 2 full rotations. We don't want to use 2 isocenters though. One should work out fine. So we're going to do 1 isocenter with 2 half rotations to get started. So if I click apply, I can then come look at our beam's eye view of one of these fields and see what it looks like. And what it does is it kind of gives you an idea of how well you'll cover that PTV with those fields. This is kind of a greenish bluish, so it's kind of somewhere in here. If it was yellow, that means Eclipse thinks you'll get great coverage no matter what. If it was, this darker blue, it thinks you would do a terrible job. But I would never pay attention to this. I just wanted you to know it changes colors and it's shaded like this when you have Arc Geometry Tool. So that volume that's shaded is our PTV. And it does that based on what kind of coverage Eclipse thinks you'll get. But like I said, it doesn't work very well. So I wouldn't focus too much on that. Let's leave this as is for now. So what this tool does is it rotates. So we said 2 half rotations, right? So it's going to rotate each of these arcs around, and at every single degree, it's going to make sure it has at least a half cm margin on our PTV. Okay, so you can see up here it gets a little tight on the top and bottom, but still greater than half cm. And if you rotate around, the reason why these jaws are opened up the way they are is because it's trying to get at least a half cm margin on that PTV. Okay, the problem is this is a really long volume. So if you look at our Y jaw right here, 2020, they're maxed out. Okay, so let's try. So I just want to show you. So if I do 10 degrees right here for my collimator angle and click apply again, you can see that it actually, in terms of coverage in the top and bottom, it gets worse. You can see, it might be hard to see here, but it's we're actually cutting off some of that PTV right there at this angle, right? So if we keep rotating around, you can see we have basically no margin on our PTV, top and bottom, all the way around. So in general, that's not what we want. But again, this whole PTV turned more yellow, so Eclipse thinks we'll do a better job with this collimator angle. But again, kind of proves my point. I never pay attention to this or listen to it because I think this would produce a worse plan than 30 degrees here. But anyways, I don't like that it's cutting off down here, so let's try a steeper angle. 45. I don't know. Let's try 30. We'll run a plan at 30 and see what it looks like. So the next point that I want to cover, so I'm going to close this. So this is just a starting point, okay? But you can manually adjust after this if you want to. You can use different collimator angles, but for now, we're going to just use the opposite. So 30 one way, 30 the other way. So that's 30 and then 330, okay? So we're using kind of the mirror image for our collimator angle, which is what I want you guys to do too. Usually that works out best. But what I want to point out, talk a little bit about, is our extras right here. So our extras are 28, 27, so that's really, really wide. But the reason why you want to pay attention a little bit to your extras is because your MLCs are only 15 cm long. Okay, so hypothetically, if I open these up real quick, pretend my optimizer wants to have all of these open like this, but it wants to move this, or let's do it over here. If it wants to block my PTV way over here with this MLC for some reason, you can see it only can move in so much, right? It can only move in about 15 cm. This MLC can only move 15 cm past the MLC that's moved farthest out this way, if that makes sense. Let me try again. So pretend I move all of these in a little bit. Now I can move this MLC a little further, right? Because all these moved in. But if I still have one of these all the way back here at this jaw, I can now only move to about 1 cm past my ISO still, because this one is all the way back. If I all of a sudden move this one will now go further, okay? So the two widest MLCs, so this MLC is the furthest one back this way. That means the furthest I can go this way is 15 cm from this one. So these two are about 15 cm apart, okay? So the reason why that's important is the optimizer is not super smart at dealing with that problem. The algorithms aren't the best at handling that situation. So what you want to try to do most of the time is limit your extra, your total X distance to about 15 cm or less. But in my experience, you can cheat to like 17, 18 without too many consequences. So usually I try to keep mine at like 17 or 18. But you also can just look at the situation and determine what you want to do. So the reason why these jaws are so wide is just because this PTV is so long. So as you rotate around, oops, those X jaws are just super wide to make sure it has the whole PTV inside of our field the whole time. But in reality, while we're planning, these MLCs are going to be they're going to be covering our PTV or inside. So if we measure, so if you look at the widest part of our PTV, and since we have our collimator, turned, we have to look kind of at this 30-degree angle. But this is about, 9 cm right here. So 14, 15, 16, 17. So it's about 17 cm across here. So that means when my MLCs are in there, they're going to be working within that 17 cm width that I was just talking about. So I'm actually, in this case, okay with my extras being this wide. If my PTV was really wide too, so it's really long, but if it was really, really wide, I would limit my extras, which we'll get into more in the next few weeks, okay? But for now, I'm okay with these X jaws being wide because my PTV is fairly thin. It's just really long. Okay, so this is how I'm going to leave my collimator, but the one thing I'm going to do is right now we have 2 half arcs, which probably look okay, but I'm going to actually make them go a little bit past 0. So I'm going to do like 330. So we're going from 330 down to 179. I'm going to do it for both. And the reason I'm doing that is because we're going to try to get it to our dose to carve out of this bone right here. And so I think if we go a little bit past 0 up top here, it'll just help it kind of curve around that bone a little bit. So our prescription is going to be 200 times 25. I'm going to save. It's always a good idea to get into a habit of saving frequently. I'm going to come into our optimizer. This doesn't matter, just click OK. This CT scanner is fine. Let's come in here to calculation models. And for VMAT optimization, instead of using PRO, we're going to use PO 15.6. That is the newer one. Let's go back in here to our optimizer. Okay, and I'm going to show you how I start every one of my VMAT plans, almost every single one. So I'm going to add an upper and a lower. I'm going to put the lower at our prescription dose, priority of 100. Put the upper at 105% of our dose. So prescription dose is 5,000, 105 is 5,250. And I'm going to leave my NTO at 100 and click start. So I'm going to let this get started. Then I'm going to pause it and I'm going to talk a little bit about this NTO. So I'm going to go ahead and pause it and discuss this NTO a little bit. Let me think here. Let me try to draw. This might not work super well, but let's say our PTV is this red circle, okay? And what this NTO is, or this normal tissue objective, what that is trying to do is control the fall off outside of our PTV in normal tissue. So if you use rings in your clinic, if you've ever heard anyone talk about rings, or in Pinnacle you kind of have to use rings or other treatment planning systems, but Eclipse has this NTO objective that is kind of replaces the need for rings. We'll still use rings, and we'll again get into that, in the next few weeks, but most plans in Eclipse, you do not have to use rings or any of those extra kind of planning only structures. You can do a lot with this NTO. And I'm only going to talk about automatic. You can open this up and switch it to manual and manually control the fall off, but I think 99% of plans can be handled with the automatic. So the way automatic works is this red is our PTV. So let's pretend this black line is our 50% isodose line. Okay, so NTO is going to look at every single isodose line. It's a continuous thing. It's not just looking at any one specific isodose level, but we're going to just explain it using one. So pretend it's looking at this 50% isodose line. Well, it notices that the distance right here, but from the PTV to the 50 line right here is only 1 cm, okay? But over here, it's 5 cm, let's say. So what it's going to do is it's going to push on the 50% line right here. It's going to try to push this whole area in to match 1 cm. Because what the algorithm's doing is saying, hey, I'm able to get that 50 line only 1 cm away from my PTV here. I should be able to do that everywhere. So it's going to try to push everywhere else into 1 cm. Where you have to be careful though is you don't always, and again, it's doing that at every isodose level, not just 50%. It's doing it at every single level beyond our PTV. And so the reason you need to be careful with it though is it's kind of a balancing act. So pretend this is a prostate and our rectum is right here. So I want to push my dose around the rectum, right? And I'm okay with it spilling a little bit on the edges in order to do that. So I don't want it to necessarily push all my dose in on the sides here, because if I do that, it'll just give more dose to my rectum and my 50 line will start to, round out like that. So you have to balance your OAR objectives, your coverage objectives with this NTO objective. Okay, it's all a balancing act. And so the way you do that is with priorities in Eclipse. So I have my coverage priorities matching my NTO priority right now. That's how I always start, okay? And depending on what our dose distribution looks like and what we're trying to do, that's when we'll change our priorities. You won't totally figure it out all in this first week, okay, how to kind of set your priorities and stuff, but I'm going to show you how I, hopefully in the next few weeks, you start to kind of understand my thought process and how I go about optimizing these plans. Okay, so I start only with my targets. Okay, I could have added my GTV and CTV in there maybe if we really wanted to, but that protocol doesn't really look at CTV and GTV dose, so we're just going to focus on our PTV for this practice case. Now these levels. I'm not going to get too into exactly how the algorithm's working from level to level, but just in basic terms, so there's 4 levels you can see here, right? Each level has a different number of steps. So I think the first level is 5. I think 2 and 3 only have 2 levels. Level 4 only has, or level 2, level 3 have 2 steps, and then level 4 just has 1 step. But what's happening from level to level is you can think of it, they're resolution levels. So you can think of level 1 as being a really coarse resolution, and it moves to a really fine resolution. And what I mean by resolution how do I make my eraser bigger? I don't know. Okay, so let's pretend, to make it simpler, that we have 2 full arcs, okay? So we have a full arc going all the way around. So in level 1, it's splitting that arc into 10 equal areas. Now I know this is not 10, but just pretend this is 10 equal areas, okay? And what it's doing is you have kind of a fluence pattern that's going, so pretend this is an arc. Okay, we're looking at an arc around the patient. The patient is in here in the middle, okay? That's our patient. And this is kind of our fluence pattern, or our intensity pattern as the arc is delivering dose, okay? So it changes depending on our MLC patterns and dose rate and all that, right? So in resolution level 1, our pattern can look like this in this first segment, and then the second segment, it can like jump way down here and do something like that. And then the third, same thing, it can jump. Maybe the fourth jumps like that. So what it's doing is it's coming up with a good plan, but it's not enforcing machine limitations yet. So it's kind of letting the machine do whatever it wants, even if it's impossible, in order to get a good plan. And then in these segments, it's kind of averaging up your beam intensity and turning it into this one large segment. So it's hard to notice on this leg because it's pretty simple, but if you do like a prostate plan or something, you'll see, if you look at really low isodos lines, like 1,000 centigrade or something, you'll see it'll look kind of like a static IMRT plan. You'll have these streaks of low dose, and that's because you're at this low resolution level, and it's split your full arc into these 10 different segments, okay? And then what happens is you see here, so in step 1, it was this is our cost function, so it's kind of telling you how hard the optimizer is working on all of our structures here. So right now it is working a little bit harder on our NTO. Your NTO will show up as your body, okay? So it's working a little harder on our body than it is on our PTV right now, but in both cases, it's meeting those. I mean, you can see here we have really good coverage. We don't really have any hot spots. The cost function is probably higher on our NTO because if you look here medially, our isotosines are a little tighter than back here. So the NTO is looking at that and saying, hey, I want them to be even everywhere, but we only have basically half arcs. That's why it's not. So anyways, that's why our cost function looks like that. And so you have to kind of, as you're planning, look at your cost function and then adjust your priority level accordingly. But we'll get into that. Back to these levels. So in step 1, it leveled out. When it levels out, that means it's not coming up with any better solutions to your plan, okay? So if it's level, it's not really making any progress. You need to change something in here, or you need to let this optimizer continue, okay? It continued and got to step 2, and what happens every time you advance a step or a level, it starts to enforce those machine limitations kind of slowly over time, and also increases the resolution. So maybe, I don't know the exact numbers, but maybe it goes from 10 to 20 or something like that. And then by the end in level 4, it's looking at all your angles and enforcing all your machine limitations, okay? That's just how this optimizer works. So what I do is I start with my targets and I'll pause it somewhere in step 1 of level 1. I'll make sure I have really good coverage like we do now, and then I'll play it until it gets to step 3 in level 1. Okay, so step 3, it'll jump, and the reason why it jumps is not because your plan is bad or anything like that, or got bad. It just all of a sudden enforces some more machine limitations, and which maybe, like I was showing, maybe it had some MLC patterns or something that was not possible, right? So that machine limitation is all of a sudden enforced, so it has to make some changes in order to get back to a good looking plan, and so that's why it spikes. It notices it has to make those changes, and now you can see it's falling. So usually I would let this level out a little bit, and actually it looks like it's starting to already, but I would let this level out a little bit and then start adding my OARs. But just for the sake of time, I'm going to start right now. So, usually I just go top to bottom. So this femoral head, we're going to treat kind of as a joint and a weight-bearing bone, but it doesn't matter. The constraint's the same for both. So we just want 50% less than 5,000. Well, we're only treating to 5,000, so we're meeting that constraint with flying colors, but we can probably get it lower. So when I don't have a specific constraint that I'm shooting for, what I like to do is come up here and add an upper GEUD. So we'll talk more in depth about this constraint in one of our coming weeks, but for now I'll just tell you that if you add an upper GEUD with an alpha value over here of 1, so that's what this A stands for up here, is alpha value. Alpha value 1 means we're looking at the mean dose to that OAR. So right here it tells you the actual dose of any constraint you add. So the actual mean dose right now is 3375. I'm just going to slowly try to walk that down. So 3,200. Targets, I always start at 100. OARs, I always start at 50. So as soon as I type 50 in there, you can see it spikes a little bit because it just added that objective into the cost function. And it's really little though, so not working too hard on the femoral head right now, but you can see it's coming down and it's pretty close to what we're asking it to do. So same thing, not much movement over here, so either I need to push play or I need to keep adding stuff here, but we will see if we can get this lower. Oh, made a typo. 300 is not what we want. 3,000 is what I meant to type in. So it's another good thing to learn though, at least with Eclipse and when you're in these earlier levels, if you make a mistake like that, just fix it and give it some time to work back to where it was, okay? You hear a lot of dosimetrists talk about like your plan blowing up or something like that, and I know in some other treatment planning systems you can kind of ruin your plan and not get it back, but Eclipse in general, if you give it time, it'll work its way back to where it was. So again, it came right down to 3,000, no problem. Let's make a little bit bigger jump, 27. So for time constraints, I'm just going to leave it at 27. It definitely looks like it's going to struggle a little bit more with 27, but over time it should kind of come down. But what I like to do is I like to push on my OARs until I start to visibly see, a considerable loss in coverage. So right now, still pretty good coverage. I'm not really seeing a big shoulder forming right here. But while I'm in level 1, I want to start to see a little loss in coverage, basically. And I do that on purpose because I want to be pushing on all my OARs as much as I possibly can. And the easiest way to know you're pushing as hard as you can is if you slowly back down, like we're doing here, you'll start to slowly see that loss in coverage, and that's when you should probably stop pushing on your OARs, or you will lose too much coverage. And then when we get to level 2, we will get that coverage back, but let me talk about that in a couple minutes. So let's move on to our femur. Same thing, 50% of 50 grade. This one though is a little bit different because we're treating the bone. The bone is inside our PTV. So if you read this document, it says no more than 50% of the bone should receive 50 gray, except when the tumor invades the bone or when there's circumferential involvement of the tumor, blah, 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 blah. So meaning if the tumor wraps around the bone, that constraint might not be applicable anymore. So we'll do our best to get dose to kind of carve out of there, but that constraint, if we don't meet it, it's just it's okay, I guess, is what I'm saying. So in this case, since the PTV is inside of that OAR, you have to be a little bit more careful about adding these EUD constraints. We're going to add one. I'm just not going to go too crazy with it, because what will start to happen is, since they overlap, these EUD constraints are pretty powerful, and it'll just cause me to start losing coverage pretty quickly. So I'm not going to push super hard on that one. What I will do is add an upper and just kind of try to get some of these high isodose levels to kind of curve inside of that bone. So maybe like that 45 gray line. Let's see if we can get that to carve out of that bone a little bit. So we'll let it think about that. Our knee is already really low, but same thing, there's no reason not to try to get it a little bit lower. And this NT strip. So we want 50% of this strip to get less than 2000. Same thing, we meet it with flying colors, no problem. But just like with all these others, we're gonna see if we can get it to go down even more. So you guys can feel free to get these OERs as low as possible, okay? That's what you should do for every plane. That's what I would do if this was real, but for the sake of time, I'm gonna pretend like this is the best I think I can get. So what I do next is I'll pause in that level 3 and let it sit until I'm done messing with my OERs and this objective function has leveled out and not doing anything. Then I would pause, or I would play it. And if it does something like that, like a huge spike, it's always best to pause it and let it level back out again. So we'll pause it for a little while. It's hard to see on my little laptop screen, but it came down quite a bit. It probably still has some room to level out, but again, for the sake of time, I'm gonna pretend like it's completely level. I'm gonna play it. You can see it's coming down, so I would pause it and let it do its thing for a bit longer, but for the sake of time, I'm going to let it get to level 2 here. So in level 2, once it gets to level 2, I like to pause. Again, make sure it's leveled out. As soon as it's leveled out, I'm going to add 2 more constraints here. So in this case, we need a min dose of 97%. That's a pretty strict constraint. That's usually not what you need to do, but since it's in that protocol, I'm going to push quite a bit harder on this lower objective here. And this lower, since we're telling 100% of the volume to get this dose, this is essentially a min dose constraint. So I want to push that min dose of my PTV up. I'm also going to add a lower at 95%, since that's what we want, 95% to be covered by our prescription dose, but I'm going to put it slightly over our prescription value. So maybe 5100, and same thing, I'm going to make my priority 140. And what I'm trying to do is just get this upper shoulder, and when I say shoulder, I mean just this curve right here at the top. So in a perfect world, our PTV on our DVH would be a right angle, right? It would just be a right angle right down at 100%, but obviously that's impossible. So we just want the shoulder to be as small as possible though, meaning we want really good coverage with very few hot spots. So I add this second objective and push on this one if I need to in order to increase our coverage. Then I'm also going to do something that you probably have not ever seen, but it works really, really well. So you can see we have this little bit of a tail down here on our DVH. So in the majority of our PTV is very good. There's very little hot spots, but we have this tail. And that tail will get bigger and bigger the harder you work on your OARs and stuff like that. And the easiest way I deal with that is, so like I said, in level 1, I push my OARs as hard as I can until I start to lose a little bit of coverage, right? And then in level 2, I get that coverage back by pushing harder on these lower objectives, okay? Which will slightly increase my OAR dose, but that's just, I think, how it has to be at this time in order to get good coverage, right? This is only our first run. So I kind of push a little too hard, and then I push harder on this, and it'll raise my OARs maybe slightly, but that's probably just how it has to be, okay, in order to get that coverage. But that's how I know my OARs are as low as I can get them. And then to deal with this hot spot, I add an upper constraint on my body. So 0% at 105 with a really high priority. So I'm going to put 400 in there. I put 400 if my CTV is, average sized or on the smaller side. If it's a huge CT, it's like half the body or more, I put 500 there. So just a really high priority, and you can see what it did. So before we had that little tail of some hot spot somewhere, it almost immediately gets rid of that. And it works. I just am saying this off personal experience, but you guys, please feel free to experiment with this yourself. It's always best to experiment with things yourself so you can see, some of this stuff happen. But doing this, for some reason, it works way better in Eclipse, at least, than pushing on this upper constraint right here at my PTV. Again, that's just based on personal experience. But there's 100 different ways to think about how to optimize a plan, okay? So you'll see different people optimize in completely different ways, and it's not right, it's not wrong, it's just how there's a bunch of different ways to do it, and you can see I do different things at different moments. So if I picked different steps, maybe my objectives would need to look different in order to get the right plan. So don't, get weirded out or anything if you see different people doing this differently. What I want you guys to do is try everyone's way out. Okay, so like in this class, I really want you, at least in these first few weeks, to pretty much do things exactly like I'm doing, just to experience it. But what you'll end up doing is slowly over time, you'll pick different pieces of what other people are doing, different pieces that you like, and kind of develop your own optimization method, okay? But for now, I want you to, try these steps out that I'm doing and see what you think. Obviously, I think it's the best way because it's how I do it, okay? If we look at our plan, you can see we have really good coverage, and it's really homogeneous. This is only 5%, so we just have those like specs of 5%, which is pretty good for a VMAT plan. Looking okay. There's a few spots, so if we zoom in here, our PTV is this green line, so up top here, for some reason, it's just not super conformal right here. So we could clean that up with a ring maybe in a second run, or since we don't have a ring made right now, you can try pushing on your NTO a little harder and see if it'll suck any of that in. The problem with this objective, or really with any objective, is it's all percentage based, right? So right in this one specific area, it's not doing great at keeping our dose conformal. But if we scroll through the rest of our plan, you can see that high dose line, 5,000 or 4,750, they're very conformal, they're very tight to our PTV. So from the algorithm's perspective, I mean, it's doing a really good job. So that's why people make things like rings and stuff like that, which we'll make a ring for this second plan, or the second run of this plan, because I think it could benefit from it. And all that'll do is just we'll give it a little bit more specific idea of what we want. So we're going to tell it specifically in this area we also want it to be conformal. Anyways, things are looking good. So I always pause it level 2. I add that extra lower. I add that upper on the body. I let it level out. And from now on, I probably won't change or add too many objectives over here anymore. I should have done that mostly in level 1. But I will adjust priority levels as needed. So if we look at our plan, it's really not carving any dose out of this bone, and maybe it just can't do that very well and keep our min dose of 97% like we need it to. But I can come here and see that the cost value, you can see it says there in that bubble, is only 2.5%. So it is not working very hard on this specific objective. Only 2.5% of the computing power basically is going towards pushing on this objective. So I'm going to bump that up to maybe 75%, or 70, priority of 75. You can see the cost function bumped up to 15%. And we can see, you know, how it does with that, if it does anything. Not doing a whole lot. So rather than push on this objective, I'm just going to let it play through and show you what we can do with a second run after this. So again, every time it changes steps, it's going to spike over here. Never a bad idea to pause it and let it level out again, but for the sake of time, I'm just going to let it keep going. Depending on exactly, you know, what each step is doing, you know, certain steps will do better than the others. Level 3 is usually pretty good. So you can see in like step 2, level 1, which was right here, the cost function was kind of stuck way up here, but now all of a sudden in step 3, it's going down, you know, below that area. So that means it's doing a better job of finding a solution that meets all these objectives. So like I said, always a good idea to let this continue working until it levels out, because if this cost function is going down, that means something in your plan is improving. So it's closer at meeting all of these objectives. The way an optimizer works though is it's all a give and take process. So you almost never are going to put exactly what you want to happen in here. You're going to put something lower than what you actually want to happen in your optimizer in order to actually meet that objective. So again, kind of see what I mean, and as you get more experience and as we move through this course. Level 3, step 2, same thing. If I would have paused it, it would have continued to come down. I'm going to turn off automatic intermediate dose just to make this go faster. If you're dealing with parts of the body that have very high inhomogeneities, like lung or any air pockets or a lot of bone or just anything like that, intermediate dose is definitely going to help you. But since Eclipse usually calculates so fast, I always use intermediate dose. But again, for this video, to make it go faster, I'm going to turn it off. It's not the end of the world. If you don't use it, our plan will still calculate. It'll still look pretty well. But what intermediate dose does is after it finishes level 4, it'll use a slightly more accurate algorithm to calculate your dose, and then it'll pop the plan back into the beginning of level 4 and let the optimizer kind of clean up anything it needs to after doing that slightly more accurate calculation. Okay, so first let's look at our min dose here. So if I normalize this plan and say I want 100% of our dose, so 5,000 to cover 95% of our PTV, click apply. It's normalizing our plan by almost 2%. It's normalizing up in order to meet that coverage, okay? Don't pay any attention to this number. It does not, it's meaningless, okay? What I suggest when you're doing IMRT or VMAT, use this in order to normalize, and then pretend I just want to heat this plan a little up. I can put this back to 100, and it's gonna, heat my plan up. I'm scaling my monitor units up, right? But in general, this is a good way to do it. So if we normalize so that we have 95% coverage, I open my DVH up, I turn my PTV on. Remember, we need a min dose to 0.008 cc's above 97%. So if I right click in here and go to absolute volume, if I click over here, I can see that the volume of my PTV is 3201.02. All right, so that means I need 3200.96. So 3200.96 cc's needs to be above 97. So if I look down here, I can see percentage. If you hold the shift key down and use your over arrows, you can move along your DVH by tens. You can see it's 4850. Oh, it's by 5s. So I'm moving 5 centigrade at a time. So we can get exactly to 97%. So 97% is only covering 3166 cc's. So we're way colder than we need to be at 95% coverage. So we have two options. We can normalize down like I showed you, or just tell it to cover more of our PTV like that, which will do essentially the same thing. But you can see our shoulder is kind of big here. We need to improve that min dose somehow. So I'm going to show you one easy way to do that. I'm going to come here to dose. I'm going to convert isodose level to structure. I'm going to convert my 100% line into a contour. I know we are meeting all our other objectives except for possibly this femur. So if we turn this femur on and I turn absolute volume off, we look at 50%. So 50% is like right at 50 gray, like right there. So I'm still thinking we need to try to carve some of this dose out of that bone. Okay, so let's go to contouring. And I'm going to do two things. So I'm going to use this 100% contour right here in order to get all of our cold spots. So if I come here to crop structure, I want to crop my PTV. I want to remove parts extending inside of this 100% line, which should leave behind all of the parts that are outside of the 100% line, aka the cold parts of our PTV. So I'm going to click apply, and you can see now that contour is all the cold areas of our PTV. So we're going to use that in our optimizer. And I'm also going to create a contour that we're going to use to try to drive dose out of this bone. So I'm going to make it about maybe a half cm away from our PTV like this. And same thing, we're going to use it inside of our optimizer. So I'm just skipping every few slices. And then I'm going to come use this interpolate tool, interpolate in between. Just make sure it's not getting too close to the PTV anywhere. Looks okay to me. Let's go back to external beam planning. I'm going to add those two in. Okay, so I'm going to add a lower on this. This contour now represents all the cold spots of our PTV, right? So it's right here, and it's less than 5,000, you know, because it's all cold. So I'm going to put slightly over our prescription dose just to try to make sure it gets there, and I'm going to do a priority of 120, so pretty high priority on that, because we really need those areas to warm up. And then this area, I'm going to try, I want to see if I can get that 45 line to kind of squeeze in on this bone. So I'm going to put a upper GEUD with an alpha value of 40. And right now it's at 4970, so let's put 48 in there to start. So 1 is average, 40 is going to focus more on your hot spots, which again, I'll talk more about this objective later on. But if you want to lower your max dose to a contour, GUD at 40 will do a good job. So we'll see what that does. Click start. I do not want to start over. I want to keep this and continue running it. So we're going to continue the previous optimization. Click OK. It's going to restart in level 4. So what I'm going to do is use my back arrow to back it up at least to level 3. Depending on what things look like, maybe even level 2. I backed it up. I'm going to pause it and see what happens. So you can see this 100 line is slowly creeping to the right, meaning that coverage is improving. You can see that line is down here and it's going down. That means it is improving. See, I'm also going to add a upper, so a max dose of 95%, so 4750. I'm going to push a little bit harder on that. We have this tail here again, so I'm going to push even harder on my body constraint. This cold contour kind of slowed down. You can see that that line is kind of leveled out, so let's hit it again. 140. And I'm going to play it through and see what we get. Okay, same thing. The minimum coverage we want by 100% is 95. I'm going to bump this down to just to 97 because I know that min dose is what we're going to struggle with for this plan. Turn it back to absolute volume. Come over here to 97%. We're at 3187. So it was at 3166. We're at 3187. So it is improving, but we're still a little bit too low. Let's just see if we bump this down another percent. $31.94, getting close. So what I would do now is I would repeat that process. So I would turn my 100 line into another contour, make a cold contour. Eventually it'll be such a small area that what you can also do is just turn on your 97 line. Scroll through here and look for our cold spots. So right here, so maybe I just make a new structure called cold. Use this pin to contour right in external beam planning. I can just contour these cold spots out in external beam planning. You can also look in one of your other views, because a lot of times that top slice or bottom slice can be cold. But remember, our slices are, in this case, they're, 3 millimeters thick. So you can actually, and you can see that contour kind of goes above the slice we're at right now, but if we go to the next slice, it's not there. Sometimes you can't even see it on your axial slices, but it'll still count that contour as cold because it's literally in between slices. So that's something to look out for too. Doesn't look like that's the case for this plan. But you know, I'm slightly over contouring this area, which is okay. It's a small area. But if you over contour it like this, so outside of your PTV, it'll just help you make sure you get that covered. But same thing, I would use this in the optimizer now, this new contour, in order to try to drive that min dose up. Missing a little here, so I would contour all that out. Same thing. So what I want you guys to do is try to meet these constraints. So you need the min dose to 0.008 cc's. You need to get that above 97. And essentially that's the only one you're going to work for. So all the other ones should be pretty easy to meet, except for this femur, but we will prioritize coverage over the femur constraint. So same thing, it's like right there at the moment. Technically 5,000 is below 50%, so we are meeting it, but our min dose is slightly too low. So you guys should be able to do something very similar. You should be able to eventually meet this min dose constraint and be right at or near 50% on that femur. So that's what I want you guys to shoot for. Okay, if you have any problems or questions, just shoot me a text or an email.